This video will cover congruence theorems in the unit of congruence. In order to prove two triangles are congruent, we must prove a minimum of 3 corresponding parts are congruent. So again, 3 corresponding parts are congruent. And corresponding parts is referring to angles or sides. There are 5 theorems that we can use in order to prove triangles are congruent. So we're going to list them here. The first one we have is side, side, side. Notice that when I say the word side, I write the letter S. We also have something called SAS. So that's side angle is where the A comes from. Side, angle, side. We have another that's AAS, another that's ASA, and the last one is called HL. HL can only ever be used with right triangles. Notice here when I'm talking about AAS and ASA, they have the same letters but they're in a different order. In order to use AAS, your side can only touch one angle. Side only touches one angle. And in the other one, ASA, the side, the S, touches 2 angles. So we have 5 theorems that we can use and 2 that we can never use. The first one that we cannot use is AAA. And we can remember this by thinking of AAA like the insurance company or like the AAA battery. Now we cannot use AAA because if we think about triangles with 3 congruent angles, we know that all of them are 60 degrees in an equilateral triangle. And if I have another equilateral triangle that's just slightly bigger, I know that this top angle is congruent to this top angle because again, they're all 60. But if you look at the sizes of those triangles, they're not congruent. One is bigger than the other. So we can never use AAA for that reason. The other one that we can never use is SSA. If you look at that word and you read it backwards, you get a bad word. And so the trick to remembering that you can never use it is that it's a bad word spelled backwards. And there's actually a mathematical reason behind this, but we can get into that at a later point. So for this first example, we're asked to determine which pairs of the triangles are congruent. If the triangles are congruent, we're going to state the congruence theorem that would prove them congruent. We might have to do a little bit of additional marking here, such as something called the reflexive property. That's when we have a shared side or angle. So in this first example, A, I notice that RT is in both triangles, RST and RQT. So here I can mark RT congruent to itself because of that reflexive property. So then when I mark up my picture with S's and A's, I notice that I have 1 side, 2 sides, and 3 sides. So these triangles are congruent by side, side, side. Notice that I only marked up one triangle. I focus on one and I mark it with S's and A's. That's the way you want to do it because if you start jumping from triangle to triangle, you might mess up the order in which your letters go. In part B, example B, I see that I have a right angle, so that's an A. I have a side and a side. Now when I read this, I notice that my angle is only touching one side. Again, this angle, my right angle, is only touching one side. So this reads to me as SSA. Oh shoot. We can't use that, remember? SSA is that bad word spelled backwards. So instead of using S's and A's, because it's a right triangle, we get to try HL. Remember, HL is used for right triangles. H stands for hypotenuse. And L stands for leg. So I look for the hypotenuse, always across from the right angle. So I'm going to relabel this as an H instead of an S. And then a leg makes up part of the right angle. So this here is an L. So instead of SSA, we now have the triangles congruent by HL. Oops. In part C, we notice that we have a set of angles, a set of sides, and there's nothing else here. But remember that in order to prove triangles congruent, we must have 3 pairs of corresponding parts, whether they're sides or angles. If I look at this picture, I notice an X being formed out of the 2 triangles. When we have an X, we're always allowed to mark up the angles opposite one another. These here are called vertical angles. And vertical angles are always congruent. So that gives me another set of angles. So I can prove that these 2 triangles are congruent by ASA. Remember how we talked about the order of ASA and AAS actually matters. And we'll see how that works here. My side that I marked up as an S is touching 2 angles that were marked. My side again touches those 2 angles that were marked. So my S, my side, touches 2 angles. ASA. Go ahead. Let's see if you can try the next few on your own without me. Pause the video to mark up your diagrams to determine if the triangles are congruent. If they're not, state none. If they are, then state the triangle congruence theorem. Replay the video when you're ready to check your answers. Okay, so here you'll see in part D that the triangles are not congruent. When you mark it up with S's and A's, you end up with SSA, that bad word spelled backwards again. And if you try HL, you're actually wrong in trying to do so because we don't have right angles here. Remember, HL can only be used with right triangles. In part E, we should have had SAS because you can mark BC as reflexive. It's congruent to itself because it's shared. It's in both triangles. So here again we have SAS. In part F, I was able to mark vertical angles congruent. Those are happening here. So that gave me another set of angles to give me a total of 3 congruent corresponding parts. So now I have an A, and an S. And if you read this starting with this A on the left going towards the S, you might say that this is ASA, just by reading the triangle and your markings. But remember that this side is only touching one set of marked angles. It's not even coming close to touching this angle out here. So my S, my side, can only touch one A. So you can either write this as SAA or AAS. At this point, if you've missed something, you can go back, rewind the video, and play it again. Otherwise, move on to your practice.